So today our topic is bisection method. The bisection method is an approximation method to find the roots of the given equation by repeatedly dividing the interval. This method will divide the interval until the resulting interval is found, which is extremely small. So, bisection method. Before learning this method, we have to learn what is nonlinear equation. The first nonlinear equation in algebra is well-known quadratic equation like ax square plus bx plus c equals to 0 where a not equals to 0. And all the students are familiar with the solution of this equation, that is Sridharacharya formula x equals to minus b plus minus root over b square minus 4ac by 2a. The formula for the roots of general cubic equation is more complicated. Accordingly, except in special cases, we prefer in practice to use a numerical method to solve polynomial equations of degree higher than 2. As for example, x cube minus 2x minus 5 equals to 0. Another class of nonlinear equations are transcendental equations, which consist of functions like e to the power x, sin x, log x, etc. Useful analytical solution of such equations are rare, so we are usually compelled to adopt numerical method. Now the concept of bisection method. Let f(x) equals to 0 be our given equation. So here f(x) equals to 0, so value of x is the root. Now find a and b such that fa less than 0 and fb greater than 0. So this is fa less than 0 and fb greater than 0. Find the first approximate root using bisection method. So x1 equals to a plus b by 2. Say this point is x1. Now what you have to do? Calculate fx1 and examine the sign. If fx1 is less than 0, root lies between x1 and b. And if fx1 is greater than 0, then the root lies between a to x1. But in our case, in this figure, root lies between x1 and b. Now what you have to do? You have to calculate the second approximate root. So the second approximate root, that is x2 equals to x1 plus b by 2. So this is x2. But if the opposite case occurs, means if fx1 greater than 0, then root lies between a and x1 and second approximate root is given by x2 equals to a plus x1 by 2. Okay, but in our case, in this figure, x2 equals to x1 plus b by 2. Now again you have to check the sign of fx2 and we have to repeat the same procedure again and again until the required accuracy of root is reached. So the working rule. Let fx equals to 0 be the given equation. Find a and b such that fa less than 0 and fb greater than 0. Find first approximate root using bisection method. X1 equals to a plus b by 2. Then calculate fx1 and examine its sign. If fx1 less than 0, root lies between x1 and b and second approximate root is given by x2 equals to x1 plus b by 2. But if fx1 greater than 0, then the root lies between a and x1 and second approximate root is given by x2 equals to a plus x1 by 2. Finally, calculate fx2 and repeat step 2.1 and 2.2 until the required accuracy of root is reached. So take one mathematical problem. Find a root of equation x cube minus 2x minus 5 equals to 0. So what is fx? Fx equals to x cube minus 2x minus 5. So first we have to calculate the value of f0. So if the value of x equals to 0, we get the result minus 5. It is negative. Now calculate the value of f1. X value is 1 and we get the result minus 6. Now calculate the value of f2. X value is 2. We get the result minus 1. It is also negative. Now calculate the value of f3. We get the result 16. It is positive. So the root lies between 2 and 3. Now calculate f2.5. It is 5.625. It is positive. So we can say that the root lies between 2 to 2.5. So the root lies between, because it is negative and it is positive, so the root lies between 2 to 2.5. Now this table, there are 5 columns. First column is for number of iteration, second column for a value, third is for b value, then x equals to a plus b by 2, and then fx equals to x cube minus 2x minus 5. Now for first iteration, what is the value of a? 2. What is the value of b? It is 2.5. What is x? X equals to 2 plus 2.5 by 2. And then calculate fx. F 2.25, it is. Now see the value of fx, it is positive. So we can say that root lies between 2 to 2.25. So if it is positive, you have to change the b value. If it is negative, you have to change the a value. Always remember, if the value of fx is positive, then you have to change the value of b. If value of fx is negative, you have to change the value of a. So it is positive, so you have to change the value of b. So iteration number 2, value of b is 2.25, a is same 2, and calculate x and then calculate fx. It is positive. If it is positive, you have to change the value of b. So value of b is 2.125. Iteration number 3, a is still 2, calculate the value of x and calculate the value of fx. Now see, value of fx is negative. So if it is negative, you have to change the value of a. So I repeat, if it is negative, you have to change the value of a. So the iteration number 4, value of a is 2.0625 and value of b is same. Calculate the value of x and then calculate the value of fx. It is again negative. So we have to change the value of a. So value of a is 2.09375. So iteration number 5, value of a is 2.09375. B is same, calculate x and calculate fx. See, it is again positive. If it is positive, then you have to change the value of b. So iteration number 6, value of b is 2.10938. A is same, calculate x and calculate fx. Again it is positive. If it is positive, then you have to change the value of b. So iteration number 7, the value of b is 2.101565. A is same, calculate x and calculate fx. Now it is again positive. If it is positive, you have to change the value of b. So value of b is now 2.09766 and value of a is still same, and calculate x, calculate fx. Again it is positive. If it is positive, you have to change the value of b. So value of b is 2.09570. Value of a is same, calculate x and calculate fx. Now again it is positive. If it is positive, then value of b should be changed. So our new value of b is 2.09473. Value of a is same, calculate x and calculate fx. Now see these two values. It is seen that the difference between two successive iterates is 0.0005, which is less than 0.001. Thus the result agrees the condition and we should stop here. So these are your homework. Try to practice this problem and feel free to ask any question. This is your exercise. Try to practice this problem and feel free to ask any question. The answer is given by the blue ink. Now I am showing the total problem set. For getting more and more updates, please like, share, and subscribe my channel. That's all for today.
Thank
Thank you.
you.